with the which we think the most important feature, the variant annotation feature. Variants coming from NGS or GWAS studies, those have become increasingly popular, especially from whole genome sequencing and whole exome sequencing. It's fair to say that the overall usefulness of variants are highly determined by both the level and the content of annotation of that variant. So even before we officially released KineticsDyn, we decided to expose this part of software to general usage because we think it's extremely important for users to be able to easily handle variant annotation in a way that they prefer. Variants can be used for a lot of purpose. I think everybody was aware of that. But there are many ways of doing variant annotation, and Omicsoft, after having several rounds of collaboration with different users, also hearing from our users, we decided to actually take a different approach. So the Omicsoft approach for variant annotation is that we annotate everything. So this everything means if you have a VCF file with 50 or 150 million variants, for example, from dbSNP or from 1000 genome, which has 85 million variants, we still want to be able to annotate them and visualize them and make them immediately available for every single user. But then we allow users to use the filters. So the key thing is the dimension of this variant. It could easily be hundreds of millions of variants if you are doing whole genome sequencing, or at least tens of millions if you are doing exome sequencing. It could be applied to hundreds of samples in the VCF file. It could be applied to thousands of samples if you have like a Plink bed file that comes from GWAS study. We want to enable the users to filter the annotation results from 150 million to 1 in seconds using these filters the user prefers. We work on VCF, imputed VCF. I will talk about GWAS imputation a little bit later on. We also take Plink bed file as long as this bed file was well defined by established panel file. We even work directly with RSID. We have the biggest RSID collection from the latest version, also from the historical RSIDs from previous versions. We even take general genomic text file. It's called GTT. It's a generalized VCF file, essentially taking the first 5 columns of VCF file as the only requirement. So on the other hand, Omicsoft also compiles a big collection of variant level annotation sources and updates this on every 6 months. We just released our 2016 version of these annotations for user to use. Currently, this module, we prefer users to use this module for human, but for other species, because the annotation sources are very limited, and also the I think except for mouse, they really don't have a so-called dbSNP and other things. The user still is encouraged to use the previous variant annotation module for other species. So on the annotation source side, we roughly categorized the information into basic information, which includes like dbSNP ID, coordinates, reference, alternative, gene information, protein, or domain information. And the second category would be functional mutation, regulation, conservation, anything that we either predicted or published from existing studies such as GTEx for EQTL information, like those CAT scores. So those are what we think the second category that describes the variant information. For allele frequencies, we compiled 1000 genome, exact ESP6500. This also can be applied to internal sources for allele frequencies. And then probably the most interesting part would be the clinical disease or drug side of things. So this will be potentially coming from GWAS catalog, WISP2, which is a broader catalog of GWAS studies, but I guess ClinVar is becoming more and more interesting. So we compile all these sources at the variance level, and when the user start to annotate their own data set, by default everything was checked. But the user obviously can work on a subset of these annotation sources to get the information they wanted. So we built up a novel technology to instantly visualize and filter hundreds of millions of variants with basic users' laptop. And this laptop can either be used as a standalone desktop application or connect to a server. But in either case, the memory usage is very small. So the user just, even though it works on, like in this case, 85 million rows, just do the same thing as what you did on a gene table. Just filter the table as you want. We can even instantly filter by list of RSIDs up to 10,000. So if you want to extract 10,000 RSID from this annotation results, simply provide that list, which I will actually show in lab. So that's a convenient function. But in practice, people filter by gene, function, frequency, or anything that can actually, anything that was annotated, like those functions, EQTL information, frequencies, whatever that annotation provides for you, you can use it for filtering purpose. And when the table, obviously, if you want to export 85 million rows, you still can. It just take a very long time. It doesn't take a lot of memory, but it will take a long time. But you can filter first, and when the size of the table is manageable, you can start to export this in Excel or text file. So this actually works on either local mode or server mode. I just want to mention that everything seems very fast and straightforward. But as long as you can wait for, could be hours, a few hours for the first time for downloading these compiled sources, because these sources are big. For a slow internet connection, it could take hours. But then after that, everything will be very smooth. So that's the first feature, and I think I'm going to demonstrate a little bit after the presentation. The second feature, or a list of features I want to mention, is the GWAS modules. So those GWAS modules were designed for the increasing needs from PGX efforts. So it's different from the sequencing-based approach in that for these GWAS studies, a lot of time, XM array or those Illumina Affymetrix arrays are involved. Usually, the analysis is the whole process is quite different from sequencing-based technology. So we designed streamlined workflow for end users. So even for users who are not in statistics genetics area, they can still use the standard pipeline to run the QC, run the analysis, run imputations. Everything we use is based on standard tools. One distinguishing feature is that we actually fully support cluster to speed up the computing. Something like imputation takes a lot of time, and when doing this in practice, we actually, this is the first set of features that we require server running on Linux, because the tools for imputation takes so long that it really requires a lot of computing to get it done. So as you can see, that we have a GWAS menu in ReStudio, and starting from preprocessing, we have QC, imputation, association, and annotation, which I will describe briefly for each module. But you get the idea that that we are actually officially working on this GWAS area will continue to improve the process. But because these modules are relatively newly designed, we actually we have learned from last 8 years how to write these modules in a way that works with classes, but also make it easy for end users. So the basic workflow is just what the menu suggests. Start from preprocessing. So this could include some sort of conversion from different formats, strand normalization, allele swapping, or what we call allele normalization. On the QC side, we will do mark and subject level QC. We will do relateness analysis, Hardy-Wenge equilibrium. We pull the data from Watson G to do population structure estimation. We calculate these eigenstruct vectors for later association analysis. For imputation side, we do phasing imputation with automatic trunking and merging. So this process usually will take a lot of computing, and we actually suggest the user connecting to a cluster to get this type of system. And then we provide a comprehensive association analysis based on quantitative binary and survival traits. After the association report was generated, we used the existing annotation report function to annotate everything, including those hits with small p-values. But the practice is to annotate everything. So some simple descriptions of each module. The preprocessing module was designed for raw Plink files where strands and alleles are not standard. This is very common in practice, especially for historic data. This is almost always required for Illumina platforms, or if the Plink file was actually manipulated to some extent. In that case, allele 1 and allele 2 probably have already been swapped. This module still needs to be run. So one distinguishing feature of this module is that it's smart enough to determine how the data was exported. So for Illumina, you could have many different ways of exporting data. You based on top-bottom, it could be based on assay strand, or it could be a reference strand. Or you don't. A lot of times, even the people who have the data don't know how this data was exported. But it doesn't matter. We actually will automatically determine it for you, and that process is completely streamlined. As long as you can tell the software that what panel, that what Illumina array was used for the data set, because we have built all this, all the Illumina panels. We have built all those different strand information into the software, and we will determine at first what kind of like strand information, what strand protocol was used during the exporting, and then we start from there to correct the strand list. So the output file was considered as normalized, so that first allele is referenced when possible, second allele is alternative. There are exceptions where both alleles are alternative alleles, but in that case, since it will be a little bit different, but we guarantee both alleles are on forward strand. And also, there are, for some historical panels, there are cases where those SNPs actually are deprecated or unmapped, and they will actually be removed during this process. So this is essentially a normalization procedure that was used in the microarray area, except that it applies to SNP. So then we do the QC. We implement the recommend QC steps based on multiple tools. We remove and report problematic markers and subjects. So the family structure will essentially be determined and will be ignored to keep only unrelated individuals, because almost all the downstream analysis assume independent individuals. At this stage, we don't consider family structures in the analysis. Generate principal components that will be needed in the association reports. We generate QC BAM files that's ready for phasing and imputation. when we get to the imputation part, the important thing is that we perform automatic trunk phasing and imputation. The user can determine to use mark or happy UR for phasing. Happy UR is much faster. We use minimax 3, which is much faster than minimax 2. So if you have something like around 1,000 samples, this will be very manageable to use our pipeline. If you use Mac, that will be slower. Automatically generate and convert output trunk files into a single VCF.gz file, because eventually we want users, or we hope users, to store all those QC genotypes and also imputed genotypes, as well as all those VCF files in the genetics land, where a centralized variant management system was provided. But for this particular, for the analytic part, we don't want users to deal with hundreds of trunks. We want them to have a single compressed VCF-GZ file with the dose information, as the both to serve both purpose, both perpetual storage of these imputed genotypes, but also the starting points for association analysis. So for the association side, we work on VCF or VCF dose, which is recommended for imputed data, or Plink output files. So if you have a Plink file and you don't want to do imputation, you can still use these association modules. So we work on quantitative binary and survival traits, take any combinations of continuous and categorical covariance. So we do Cox model for survival traits, we do logistic regression for binary traits, or general linear model for continuous traits. The results are definitely reliable. We benchmark, so we have done this for the last 8 years. We benchmark all the statistical model with both SAS and R. And because we potentially can work on 30, 40 million imputed genotypes on a rather complicated model, this procedure was also parallelized. So it's parallelized by markers. So if you have 100 nodes, then the analysis will be accelerated by 100 times. So after this annotation was generated, where you still get a single report, even though the markers are truncated to do the parallel analysis, the eventual output of the previous module is still a single report. We understand it could be big, but it won't be bigger than things like dbSNP, where 150 million variants are found. So in practice, you may get 20 to 30 million variants in the association report. We ask user to provide annotation for all these variants and then filter from there. So the module that works with VCF also works with the association report. And this is where the user starts to get what we call big tables that will fully support in 9.0. So that's the second feature I wanted to highlight at this stage for genetics. Analytics, even though we have tried very hard to benchmark all these modules, a lot of these modules actually are based on open source tools like Minimax 3. We think that we want to work with users closely to improve these GWAS modules. But then let's actually move on to something that's not so variant or genetic centric. The third feature, which I think will be useful to improve the experience for like biologists who actually don't use ReStudio for data analysis, but use ReStudio more for land exploration. We have a new simplified graph unit for land users called ReStudio Land Mode. So if you go to ReStudio, you will see actually a simple full screen icon that's located on the right part of the top tab. Just click that, and then you ask your question, accept yes, you will get into this so-called NAND mode. So this screenshot shows you what a NAND mode actually what looks like. So in this case, the user will be able to focus on LAN only. They can still do pretty much everything that they can do with full mode or the so-called standard mode, but they do have more space for LAN exploration. They don't have this kind of additional server tabs and analysis tabs that they may never use. And also the menu was hidden here as a drop-down. So we found that a lot of times when the user was using RStudio for like OncoLAN or ImmuLAN, they don't care about a lot of other features, and they don't use other features. So if they do that, then the NAND mode will be much more intuitive to use. Anytime they feel that they want to use the full standard mode, they can go to the menu and then go to just choose the menu to get back. But even with LAN mode, the user can still, anytime when a genome browser is needed, for example, if they want to stream a TCGA BAM file or BAS file, they can still, in that case, the genome browser actually will be popped up as a separate frame, and they can even use a different monitor to have the full genome browser experience. So we think that this simple NAND mode will actually help some of the users who are more comfortable just working on the NAND. RStudio Launcher, this is actually one of my favorite feature for 9.0. In the past few years, we have occasionally heard from users saying, oh, Omicsoft is awesome because it provides software updates every day, but it could also be very annoying because every time I need to update the software, it could take a minute. And I have to do this every time I open RStudio. So we try to address those issues. We actually we have been practicing different approaches, but I think the 9.0 RStudio Launcher is really an awesome feature to address these needs. So now we have, I think for existing users or first-time users, as long as they are upgraded to 9.0, they should see a desktop shortcut. It's called RStudio Launcher, just like RStudio Latest or RStudio 8.0, something like that previously. When they click this RStudio Launcher, it actually works with any browser. So no matter if your default browser is Chrome or Firefox or IE, actually will work. It will not launch browser window at all. And the most exciting part is that when it's starting RStudio, you will check if there is a new version available. Most of the case, I would bet that there will be a new version because we do this on a daily basis. But then you can decide if you want to ignore this version or if you want to accept the version. Assuming you accept the version, then you will use the faster downloading mode. So it will only take 2 seconds most of the time. If not, let our support know, and we'll find a way to make that faster for you. So the downloading of the updates will only take 2 seconds. And you can decide if you want to do it, but also anytime if you are on an extremely slow internet, or if you are like at a place that you don't have internet but you still want to use RStudio, so you want to have offline usage. In previous versions, offline usage is possible, but usually it's very hidden. And but if you in 9.0, if you want to do offline usage, you can always just go to My Documents, Omicsoft, RStudio Latest, and then double-click RStudio.exe. I mean, this is not like it's recommended, but it's there if you don't have internet access, and you will get the last version of RStudio. So we kind of recommend or require everybody upgrade to 11.0. If you are a new user, just use this link, the standard link that's from our website, to click install. Make sure to do this in IE, but this is only required for the first time. Later on, as long as you have this shortcut on the desktop, you are good to go. For existing users, you probably have already seen this launcher because the software itself will automatically create this shortcut. But in the worst case, just delete any RStudio icons from your desktop and click this link from IE once. So if the current automatic way does not work for you, just think of yourself as a first-time user. So we hope that this will simplify RStudio updates and launching a lot easier than previous versions. So now let's get back to variant management again. So I've actually talked about some analytics, also some variant annotation. But for users, like they have some VCF files and Plink files, or even some EQTL data sets, and when they start to use our variant annotation, they will generate OSCR. Those are annotation results from Omicsoft. When they have this kind of files together and they want to have a centralized way to share this and just to organize this information, they can use the variant management system that's built-in functions for existing NAND users. So you don't need to purchase extra software or even genetic NAND to be able to do this. So it's designed for simple file-based management, but it works fine in practice. It's very easy to use. So it works for VCF, BED, EQTL, GTT, and OSCR. EQTL could be built from microwave plus SNP. OSCR is Omicsoft annotation results. GTT is a generalized VCF file. So as long as this type of things are file-based, just like if you have a set of BAM files and you want to manage, here you have a set of VCF files and you want to manage. We still recommend genetic NAND as a centralized variant database because that will allow you to do cross file search. But that won't be available until May, where we will officially release that product. So this actually gives you some idea of how to actually organize these different VCF files, different resource files, and be able to tag, organize, and share them. So if you have questions about this, contact our sales or support. I know it could be a little bit confusing, especially if you haven't actually worked on our variant annotation, other genetic functions yet. But just want to let you guys know that it's available. NGS has been the central component of Omicsoft development for the last, I would say, 4 to 5 years. Because the modules have been stabilized, the technology has been mature, we have seen heavily used, especially on our RNA-seq pipeline, in the past 3 years. So for example, Omicsoft alone has processed more than 30K RNA-seq samples as part of NAND delivery. The standard pipeline makes everything very consistent, but also because it has been used in so many cases, we don't feel that actually there is a need to change the results or modify results. Instead, we spent a huge amount of effort last year to optimize the downstream modules. Except for very, very few minor bug fix, everything in 9.0 gives the same results of this RNA-seq pipeline or DNA-seq pipeline results as 8.0. But it's fully optimized. So the speed will usually speed up is between 50% to 100% for some of module. And this pretty much applies to every single module like QC, counting, Exon junction, mutation calling, batch generation, and other things. And also, because cloud was becoming more and more popular, we optimized this kind of modules for cloud as well. So for example, we know that for some companies, it will take like 10 minutes to launch a new instance. So we usually try to bundle everything together in one module, like the RNA-seq pipeline, so that they don't use this spin off this Amazon instance for every single analysis. Even that analysis itself could just take like 2 minutes. So like the new RNA-seq pipeline, one of the major improvements is that there is a button called generate non-LV files. So when you do the RNA-seq pipeline, you can automatically generate LV files, which is essentially NAND-ready. So when you run the NGS pipeline, you also made it immediately available for land. So that's kind of the concept, and it has been fully tested. We strongly recommend users starting to use this standard pipelines for land. So on the visualization side for NGS, we spent quite some time making our, I guess, widely popular genome browser even more efficient. So we redesigned the background loading for genome browser. So this screenshot shows you where we're trying to exaggerate, these capabilities, and just to show off how the user can use a ReStudio to handle hundreds of BAM files, like high coverage BAM files. So in this case, background loading actually will help, because you would not imagine everything will happen instantly when you have hundreds of BAM files. So it's optimized for cloud storage. If you have BAS files, which we always generate during the pipeline, so those are BAM summary files, you can easily work on hundreds of them. If you have BAM files, dozens of them are not a problem. So we also redesigned the BIM file, which is our indexing file for BAM file and BAS file. So it works much more efficient now on repetitive regions. If you have older formats of BIM file that you never recreated, that's fine. We still fully support them. If you have public BAI files and you don't want to regenerate the more efficient BIM file, that's okay. We'll also take BAI files. So if you are really serious about BAM browsing, one recommendation from us is to delete existing BIM files and re-index BAM file to take advantage of the new format. So we also added some features requested by the users to enable Exon junction care. So previously we have an extra Exon junction kind of like layer that the user can, if you move here, mouse move here, then you will be able to show it. But now we kind of integrate the Exon junction counts as part of coverage. I think it's a smart idea suggested by a user. This shows you how to actually get there. If you're working on GWAS or some sort of association analysis, region plots are, I guess, extremely important to highlight the region of interest. So we provided on-demand region plots as part of the genome browser improvement. It works best on annotated association reports. So, I mean, yes, you have p-values, you have all the ratios, but we also want you to use our tool to generate these additional annotations, which then can be used to filter interesting results. So one analytic part of this module is that we'll automatically calculate LD based on a given 1,000 G population. So it could be European or Asian, East Asian, or a population of the choice. And the user can choose R square or D prime or haplotype based R square to do this region plots. So it's also, because it's a genome browser track, so it's also integrated with other tracks. So this is actually a very attractive feature for users to use our kind of server management system, variant management system, to be able to get on-demand region plots. There are a few other like minor input, but I think we thought like it could be very cool, simply because it's so easy. As long as the user is aware of it, they can start to use it. So one such feature is Violin plot. Based on a user request, Violin plot was designed to combine box plots with kernel density. In practice, our internal team found that it works particularly well for larger of samples per box. For example, TCGA, each tumor type could have hundreds of samples. So in this case, if you want ready to see the kernel density or some sort of like bimodal or multimodal distribution, just change the gallery to Violin plot. So it's very simple to use, and sometimes it could be very intuitive to be able to tell the distribution of the data points. This is what we think is probably the most important graphic user interface improvement in 2015. Even though it probably has been widely used, I still want to point it out. So for those of you, you might wonder, there is a button for each query. What does this button do? You probably never tried to click it, but try. If you click it, it actually, this serves as a smart button where the behavior of this button will be dependent on the context. So if you have like a string columns, for example, gene symbol, it actually will allow you to search through all these values. You can search up to 10 values and do multiple kind of selection. If the button, if the column or the variable is actually a factor column, then actually you will be able to combine the single selection and multiple selection. And also, if you right-click on that variable, it will give you an option to provide a list without creating a list. So what does this mean is that previously, if you want to filter your table by a list, you have to create a list in Solution Explorer first. But now, if you really just want to be able to filter without even bothering creating a list, you can do that. And this actually is especially useful for large tables. So streaming big tables. This is what we think the novel technology that actually we created in the past year to enable us to be able to visualize these big tables. We have already seen pretty big tables from mutation results previously, but with the VCF files and those Plink imputed files, we found that we could easily get to hundreds of millions. So this is where we start to develop this technology so that instead of importing this kind of tables, we just string them. Just like when you have a BAM file, nobody will actually open BAM file or those SAM files in as a big table and try to browse them. People just use the index DAI file, try to find a particular region. But streaming actually takes one additional step further to be not able to just search for a particular region, but also enable the search by, for example, identifiers, RSIDs, but also allow user to actually be able to see everything of them. Just not like a loaded way, in a streaming way. I think I will quickly show this. Extremely low memory footprint. Otherwise, with 150 million rows, you can easily face RStudio or the computer, no matter what you do. So OSCR in particular, extremely efficient on everything. Also, there were a few other things that I don't have details, but I just want to announce them. Every server 11.0 has a 4 times speed up for non-initialization. This only happens to the version that's what was released this morning. So now, no matter how many lands that you have, even you have every single land that Omicsoft provides, should only take 3 minutes to load. Server project search was basically redesigned. So now it should take constant time, like should always less than 3 seconds, unless you have an Oracle database, which will be a little bit slower, for any number of genes or projects. And the project listing is based on the filtering report, which means that you can do multiple filtering criteria, not just the single criteria previously that displayed. And also, we actually try to clean up the data for, especially historic data for user from our side. So if you have different cases like capital case human or lowercase human or everything uppercase human, they will automatically be aggregated when you actually see the results of this project list. And also, from our support team, we have started to build dozens, even hundreds of videos as part of our wiki system, because we think that with a video and also those video annotations, it's much easier for user to understand our software. So take a look at this link, and you will start to see a lot of organized videos, organized and annotated videos. So before I spend the time on like 5 minutes, 6 minutes on the demo part, I wanted to talk about what's going to happen next. On early February, essentially the end of this month, we'll release oncoland, immuland, and also first visual release of cardiovascular and metabolic land. We still call it 2015 Q4 because we froze this data at the end of Q4, and then we process them, which takes a month, usually a month, based on those frozen data. And for Omicsoft as a company, in 2016, we have 3 major focus. We'll continue to work on genetics variants and the variants so that we will deliver genetic design as a product. We have been actively working on web clients, so in the future we'll have a studio for bioinformaticians and some advanced biologists, but we'll also have a web version for biologists. And we'll continue to increase the value of the land content. So we have essentially have plans to double, even triple our efforts on different land contents. So one example is that we have been working on DNA-seq genome mutation on different projects that we previously we didn't actively do, we just import, but now we actually process. The biggest next thing would be the Omicsoft user meeting. This will be held in Boston. Some of you probably have already received emails from us. So this meeting, I personally invite everybody, and obviously our sales team and support team will invite you as well, but I just want to use this opportunity to invite you guys to be in this meeting, to hear exciting updates on oncoland and disease land, and we will also officially release genetics land. If you are a super user, we'll have panel discussions with all the super users, so that pretty much will determine what Omicsoft will be focused on next. You will hear talks from end users, but also from Omicsoft on new features, and you can schedule basically unlimited parallel one-to-one support training sessions with our support team during that area. So if you are actually in Boston, make sure to book some time to talk with our support team and get your problem solved. The registration is free. If you're in Boston, basically the fee is minimum. If you're not in Boston, we still recommend that you go to Boston and talk with Omicsoft and other users. So that's pretty much the foundation part. It seems that I don't have a lot of time to do the demo, but I still I wanted to touch base a few things, some simple things, but also some complicated things. So I guess I will start with ReStudio, some simple stuff. So the first thing you notice is that this is a Violin plot that kind of like a fancy gallery for the very popular variable view. You see this button, a gene symbol. So previously, you type a gene here, or you can right click and add a list. But now if you click this button, you actually will be able to see all the genes, and you can actually start to search. So that's a little bit different from before. But also you can choose multiple values, so that you will automatically create kind of a filter for you that will know it's either EGR1 or any EGR1. Or you can right click and say, I want to add a stream filter, but I want to input this or load this from a file. So you can do something like this. Just input and get essentially the same results. And in this case, it's input two values. If you click the button again, you will see these two values, and you will be able to add or remove. So this happens for a stream filter. But if you have like a factor, when you click this button, you can see that this user interface is not only give you this searching capabilities when the level number is big, but also allow you to choose either one, in which case it's essentially a radio box, or if you choose multiple, in which case it's essentially a combo box. And you can see the interface was updated. So previously you have to do something like this. If you have hundreds of levels, it could be a bad, experience. But now click this button, and then choose a way that you like, or search based on the value. So that's why we think it could be, we think it's convenient for the user to increase the experience on query controls. So the next feature I want to demonstrate is streaming tables. This is what we think is a breakthrough technology. So now, if I have a big VCF file, I can start to stream this. So I choose a VCF file format, and then I choose a VCF file. This VCF file is CCL, all the CCLE Exon sequencing VCF file based on GATK pipeline that's processed by us from the last release. So we choose this VCF file, and this VCF file obviously is very big. It's 14 gigabytes. And you can see after a few seconds, I'm able to see, in this case, I think it's 2 million, a little bit over 2 million variants. I say essentially, even though this is streaming, you still be able to scroll down or even export every single row. So if I click a row, it will automatically split this VCF text for you, so you will be able to get the details. But the most important thing is that you will be able to filter to a given row, and this filter can either based on SNP ID, like I just tried the RSID, or I can try just like a region. And then you will be able to subset this VCF file for you. Now you can easily export this based on the region of interest. So it's kind of like like TBI indexing, but doing this from the graphic user interface. But also TBI won't allow you to search for RSID or ID itself. Now we actually will be able to search for RSID. But also And one really cool feature is that you can actually just provide an RSID, a list of RSIDs. So, and then if you want to say, oh, I want to see the VCF results of these RSIDs, you just choose, use this feature that I just mentioned, and then be able to filter this into 71 RSID that I just provided. So that's the idea of table streaming. This applies to VCF. This applies to a VCF on the server file, in which case you will need a server project and add a server table to be able to do the same thing. So we expect this feature will be used more and more with the 9.0 release. And a lot of times, this is our way to deliver huge tables. Because if you have a table very big, you won't, like in this one. In this case, you can see we have 85 million rows. So traditional ways were not able to provide anything for this table unless you are really an expert and try to do different indexing or different things. But now this full table is fully searchable. So for example, I can start with this 80 millions by first say, okay, let's go to quinoa and choose things that's pathogenic. Excuse me. Now I easily filter this into 1,727 variants, because you will not expect a lot of pathologic variants from 1000G data, which are normal, healthy controls. But then you can see, we want to say those pathologic variants with some sort of regulation information. I'm just trying to fake here. And you get a smaller list, 102. You can go to functional mutation and say, I want to say the shift prediction to be damaged. Now I got 47. You can even go to conservation information and say, I want this to be relative conservative, so at least 90%. Now I got 3. Finally, I can go to 1000G frequency itself and say I want allele frequency to be 0.01, bigger than 0.01. If you click this one, you get all the annotations. Essentially you get all the annotations of this particular variant. So essentially I filtered from 85 million to one variant, use different criteria. And if you go to this advanced, some of the new features of the query, you can actually see what I did to filter this. What criteria was used. I can even save this query status, 80 million to 1. If I reset everything, now I get back to 85 million, I can actually load this query status later on. So you can see multiple status. So you will actually do a batch loading, but you can see still it's very manageable to handle 85 million rows. So that's what we call variant filtering. It won't be uncommon for you guys to generate a big table like this, but still you can see it's not going to be a problem to filter that. So the last thing I want to show is the region plots. So those are kind of advanced genome browser features that the user can use, especially when they have associating reports. Those are extended genome browser tracks that works on users' association reports that's based on the server. The user can choose regions of interest based on different criteria. They can choose different LD sources. They can even use different methods to do, like in this case, I'm using D prime or R square haplotype or R square, different methods, and you can choose different populations And there are filtering functions around this that they can use. They can use any of the annotations of the runs to filter the results. So I think on May, we will have a complete picture and complete description of genetics land. But I think for today, that's really what I wanted to show for both the software part and the demo part. So I want to thank everybody for your time. Feel free to send questions to our sales and support team. We'll continue. Omicsoft will work as a team to continue to provide the best content and the best framework for users. Thank you for your time, and have a wonderful day.
Thanks, Jack, for the exciting update. Since we are almost running out of time, and I do see a couple questions, but we will be following up with the questions individually to the audience, and we will be updating for the recordings and following up questions. And also, please check out for the updates of our Omicsoft user meeting, and we will be sending out the detailed schedule and programming soon after. Again, thanks everyone, and thanks Jack for the exciting updates. Hopefully see you next time, and enjoy using Omicsoft product using the RE Studio 9.0. Everybody have a nice day.